This section is going to cover MAT 115, so statistics, section 6.1, and we're going to talk about discrete random variables. So a random variable, when we're talking about probability, is just a numerical measure of the probability of the outcomes. So for example, we could call the variable x and we'd say it's the number of heads. And then if x is the number of heads, we can find all the different probabilities based on how many times we're flipping the coin. A discrete random variable has a finite or a countable number of values. So you can get 2 heads, you can get 5 heads, you can't get half a head on a coin. A continuous random variable has infinitely many variables. And those are like speeds or distant, any type of measurement or range. So let's look at these. Are the number of A's earned in a section of a statistics with 15 students. Well, that's going to be discrete because you either have an A or you don't have an A. An A minus is still an A, depending on how you're tracking that. The number of cars through a drive-through. That's also discrete because you can't have half a car. It's not all the way through yet. And then the speed of a car, that would be continuous because it's a measurement. And your speed can get smaller and smaller or bigger and bigger depending on how you're going to break that up. A discrete probability distribution. So when you have a discrete random variable, the distribution shows all possible values and the probability of getting them. In that distribution, everything has to add up to 1. This E right here means sum. So all the probabilities have to add to 1. And they all have to be between 0 and 1, so there's no negatives. It's the big thing. So looking at these 3, which one or ones are probability distributions? So check it out, look at it, and see what you think. Well, all of them have discrete x values, so they're all discrete. Now we need to decide if they're probability. This one has a negative, so that negative instantly makes this no, not a probability distribution. For B, they're all positive, they're all between 0 and 1, so we need to add 0.2 plus 0.25 plus 0.10 plus 0.14 plus 0.49 gives us 1.18. That's over 1, so this is also not a probability distribution. And then we're going to do, all of these are positive, so we're going to add those up. 0.2, 0.25, 0.1, 0.14, 0.31. If I add those together, I get 1. So this one is, because it has discrete probabilities, all of the numbers are between 0 and 1, and they add up to 1. Sometimes you want to find the mean of a discrete random variable. You either need that mean to estimate some things later, or you are asked to find it, and we'll show you where those come from. The mean is just like finding the weighted mean as before, or the grouped average. You're just going to take that variable and multiply it by the probability for each thing. So we would do 0 times 0.1 and get 0, or 0.01, sorry. 1 times 0.1 and get 0.1. 2 times 0.38 and get 0.76. 3 times 0.51 and get 1.53. Then we add these up. Once we add those up, we get 2.39. So that would be our mean of a discrete random variable. So whatever we're talking about, what this means is over time, if we repeated this, the average of this experiment would be 2.39. Another vocab for the mean is expected value. So what this really is, it's the expected average over time. So if I were playing a game, the expected value would be what I would expect to win on average over time. So maybe the prizes are like $5, $10, and you can lose up to $20. Over time, you're going to win some, you're going to lose some. What would be your average winning per game? That's expected value. So let's look at this in real life. Insurance. A term life insurance policy will pay a beneficiary a certain sum of money upon the death of the policyholder. So if I die, someone gets the money. These policies have premiums that must be paid annually. So every year you pay the insurance company this money. Suppose an 18-year-old male buys a $250,000 one-year term life in policy for $350. According to the statistics report, the probability that he will live, based on whatever that report did, is 0.998937. Find the expected value. So it's saying find the weighted mean. Find the mean of this variable, because living and dying you can't predict. So we have outcomes. What are the outcomes? Well, he either lives or he dies. Those are the only choice. If he's not dead, he's alive. So he's going to make a certain amount of money, or the company's going to make a certain amount of money. And then there's the probability that he lives and dies. So let's start with that. He pays them $350 regardless of whether he lives or dies. The company makes $350. If he dies, they also pay out $250,000. So we would subtract that and get negative $249,650. So they still brought in that money, but they paid it out. So if he lives, they make $350. If he dies, they lose $249,650. The probability of living is 0.998937. Probabilities have to add up to 1, so the probability he dies is 1 minus 0.998937. And if you do that math out, you get 0.001063. Now to find the mean, just like before, we're going to do the money times the probability. So I'll put the calculator over here this time. So we're going to do 350 times 0.998937, and we get 349.63. Then we're going to do the money they lose times the probability of him dying. So negative 249,650 times 0.001063. We get negative 265.38. And then we add those together. 349 plus 0.63 plus negative 265.38 gives us $84.25. So what that means is if they insure a whole bunch of people with these same costs and probabilities, they're going to make an average of $84.25 per person. So they're going to have some people live. They're going to have some people die where they have to pay out, but they're going to make enough from the people living that it's going to average to a profit of $84.25 per person. The calculator will do this math for you, which is really nice if you get some bigger ones. So what you're going to do is you're going to put the money or the outcomes. So if we're going back to this one, we would put the X numbers. You put that into L1 in your calculator. You put the probability into L2. So to get that, you hit Stat, Enter, and then we're going to type these into L1 and L2. So L1 is 350. L2, and you can either type the value you got, or you can actually type the subtraction problem in there. That's up to you. And then for L2, it's 0.998937, and this was 0.001063. So we have those numbers in there. Okay. Now we're going to hit the Stat button. We're going to arrow over to Calc and choose number one variable stats, just like we did before. But now, if you look over here, you'll see it has a choice for list, which is L1, that's where we put the money. And then frequency list, we want it to say L2, because that's where our probabilities are. To get L2, you hit second 2 on your calculator. Second is the blue button, 2. And I don't know why my calculator keeps shutting down when I do this. So you would hit second 2, and then it would calculate your money. Now yours will still say the 84.25 for whatever reason, my calculator deleted the data and put a different set in. So I'm going to try one more time really quick. Edit 350 and then negative 249,650. And this was 0.998937. And this was 0.001063. And then we're going to go stat calc 1. And I'm going to do this. And it froze again. But the X bar is really, when you get your calculator, it's going to spit out an X bar. That X bar is your mean. And if your calculator doesn't freeze like this one, it'll be the same, the 84.25. So that is section 6.1. Let me know if you have any questions.